Nashino, Nameo, Tim the Plane Man, and welcome to Plane Time Autopilot Developer Conference, Plane Follow Edition. So a few weeks ago, before the conference, just I believe it was about the 8th of October, I did this. And this isn't, well, what's going on? Oh, see, okay. Oh, no sound. It's a shame. And by the way, if I didn't mess it up, but if you watch it on your computer, you might find you get a better view than watching it on the screen. If you can see, we have two planes. They're two mini striver, about 2.1 meter wingspan VTOL planes. The first one is flying an auto mission. The second one is autonomously following it around the sky. I have two pilots there. I'm actually piloting the second plane, but all I did was flip a switch. And it's pretty amazing. So here's the view from on the plane. This is on the second plane. And if you can see in the right-hand side, there's the first plane coming up in the air. It's just coming up right there, as you can see. And again, that is just completely autonomous, telemetry driven. The little black thing you can see sticking up here is a SIK telemetry radio from Hollybro, and I have two of them. They're running at 500 milliwatts, one on this plane, one on the other plane, and there's a direct telemetry link. So MAV link is coming from that lead plane and feeding to the follow plane and feeding global position int and attitude messages that the second plane is using to figure out what to do so it can follow that plane. Again, it bears saying because it is important. I mean, we're already pilot, but that what it's doing there is detecting that the other plane is turning, and it's deciding to turn. The other plane is going to do a turn to the left a little bit, and it decides to go a little bit further to the left, and then the other plane will turn to the right to head off towards the the field where the pilot location is, and again, now it's figured out that it's turned. Of course, there's a little bit of a lag, and that's one of the challenges to deal with in this situation. But it's basically it's doing it. It's doing it. Plane follow. So to my slide deck for a second. I didn't realize this, and I'm sorry about that. But when I play the deck, and so when I play the deck, I guess I lose everything else. So I may have to do that, and because I do want to flip back and do a couple of demos on the way through. So what happened was that about 6 months ago, maybe a little longer, Hexoon, and thanks Phil and Sid, sent me a EDU 650. And one of the things that I wanted to do with it is try out the copter follow me mode that I saw at last year's Autopilot Developer Conference. So what happened was I set that up and I did a video and I posted that on my Tim the Plane Man YouTube channel. And the very first thing that people started to do was, well, that's great, Tim, but can't you make it work with a plane? You are Tim the Plane Man after all. So the challenge accepted, I started having a look to figure out how I could do it. Of course, those of you who know realize there is no plane follow mode in autoplane, the way there is in the autocopter. And so, but there was a fairly rudimentary example Lua script in the GitHub under AP scripting libraries examples. And I pulled that down, fired it up, and did a little demonstration of getting it to work. And of course, the first thing I found were challenges and problems. Um, so I did a video and I did a Siddle simulation of plane follow. And the next thing that happened was I got a big break. A company from Australia called AirGeoX contacted me. And what these guys do is magnetometry surveys of outback locations in Australia. And they send up planes like the Striver Mini into the sky with big magnetometers dangling below them in this case, and survey vast swaths of open area, fundamentally looking for gold. They're looking for the magnetic signature. Well, they're collecting the data. They give it to a geologist, and the geologist looks at it and said, oh, yeah, there's probably gold over there. And these guys have actually found gold, and there are now, there's a new gold mine, for example, near Tennant Creek in the middle of Australia, which is where I was born, that is now mining gold at a location identified by the autopilot-powered mini striver flying around that these guys do. But they said to me, listen, what we want to do when we go out and fly these things, we want to be able to fly 2 planes, or maybe more than 2, but 2 to start, because we want to have the 2 planes, as far as I understand it, fly kind of at the same time. And they want to fly them in parallel, one next to the other. And they don't want to have like 2 planes set up with independent missions where they'd get out of sync and they'd lose time synchronization. They literally want to have them fly together in parallel across and gathering the data on both planes at the same time. So they said to me, listen, we'll give you some money. We want you to build this Siddle thing that you've done and make it work on real planes. And so got stuck into it. These are the requirements. So first of all, the lead vehicle gets configured with the survey mission, but you don't have to configure anything on the follow vehicle. The ultimate target would be that the lead plane and the follow plane follow each other about 25 meters separation, but not behind or ahead, but in parallel, literally side by side. Someone who I spoke to earlier was asking about how that works. And the simple answer is that we use the same follow parameters that Copter uses. And one of the things that has is X, Y, and Z offsets. So you can simply say, follow this vehicle, but follow it 25 meters to the right, Y equals plus 25 or minus 25, X equals 0. So 0, 0 neither to the in front or behind. And requirement is around altitude. They don't want the second vehicle to follow the altitude. They want the second vehicle to have it to follow the terrain. Because of the surveying they're doing, they both want to fly about 50 meters above their own terrain, which could be obviously different if they're a certain period apart. So they shouldn't be flying a coordinated altitude. They should be flying above the terrain. So thus started my plane follow project. Started by ordering 2 mini strivers and then building them and maiden flight and test and getting them to fly. I call them the Japana and the Brolga. Good Aussie names for Japana is sunset in some native Australian languages, and Brolga is a fairly elegant flying bird that has some interesting dance behaviors in its mating patterns. What I did then was improved the simulator. I spent hours and hours and hours and hours running Siddle and got the simulator to improve. Then I flew on a real plane, and an interesting use case, a real plane following a simulator. So I simulated a plane flying around the sky, and then I threw a real plane and had the real plane follow the Mavlink feed of the simulator. Everyone but me thought I was just flying one plane, but I was actually flying 2. One was virtual. And then it was, once I got it working with my little foamies, that I didn't care if it crashed or whatever happened with, and I got some of the bugs out, went ahead and did it with the real VTOLs. And then eventually I got to the video that we saw a little bit earlier, where the planes actually follow each other around the sky. And of course, it was, lots and lots of iterations of improvements. So what I want to do now is, again, I just flipped out of the video, I guess. I'm going to switch to a slightly different video here. I can get to the window. This one is not the original Siddle, but it's the new improved version. It's a fairly recent. I recorded it a couple of days ago, so it's the almost version 1 finished version of Siddle. Vehicle 11 is the lead vehicle, and vehicle 12 is the follow vehicle. It's using one of the main pieces of inspiration I got for some of this stuff was the dual plane aerobatics work that Tridge did and demoed, I believe, at the last year's conference. And so if you have a look at the code, you'll see I harvested lots of the stuff that he did, and in particular, the ability to have to simulate two vehicles sending messages to each other using Mavlink was very, very helpful for this. So here we have the vehicle. It's doing a turn, and if you can see it, you can't really see it on the screen so well, but if you look at the yeah, okay, I'm going to try and stop that somewhere where you can actually see the. Can I get that to not pop up? Oh, there we go. Okay. I'm trying to use my mouse to point, and as soon as I put my mouse over the video, it pops up the controls, which I don't really want. So I use two ways of navigating the plane. Simulation, and also there's an example of swarming in Mission Planner that tries to do follow, especially in plane, by just dropping a location point ahead of the plane as it flies around. And that works great when the plane's a fair way ahead. But it won't work when you get close. If you can imagine, if there's a plane down there and it's a meter to the right of where you want to fly to, but I'm still flying towards it, I'm pretty much doing okay. But if the plane is right here, if the point where I'm targeting is 1 meter to the left or 1 meter to the right, the plane here is going to be flopping around all over the place trying to hit that target point because I'm right there. So what I do, and this is where that the dropped point that you can see in the map, as it flies, it keeps losing it. If you notice, it'll drop to the point, but when it gets close, that point will stop happening because I'm switching into guided heading mode instead of guided reposition follow mode. So when I get very close, I actually follow the heading of the target vehicle, and I adjust my position by adjusting the airspeed and not by trying to target the roll pitch yaw direction of the aircraft. So if you watch that, you'll see that that's what's going on. It's dropping that little point. When it gets really close, it forgets the point, which Siddle just leaves on the map, or Mav Proxy leaves on the map until it decides it needs to reposition it again. And then I have to do some. So one of the hard things is speed matching, and we'll talk about that in a second. The other hard thing is getting it close and dealing with when you need to switch between different mechanisms of navigating. And the last one is turns. Turns are quite difficult because if the lead vehicle turns, you don't really know about it in time. And so we'll see in a second, I've got some turns. It's not just a straight mission. And what it will do is the lead vehicle will turn and the follow vehicle will start dropping points to follow the other vehicle around the turn until the turn's over, and then it might switch into heading mode again. So I think this is a little longer than a straight line than I was hoping for with everybody watching me, but it will turn in a second, and then you'll see how that works. I just want to show you the turn, then I'll kick on to have a quick look at some of the code that I wrote to make that work. But it works really well. And as you can see, in the air, here we go. Here's the turn coming, and the lead vehicle is going to turn. It's just a slight turn here. So there's a kind of a threshold that I put in about how steep a turn it is before it decides it has to do a real turn. So it did a little bit of a turn. It lost track, it started dropping points again until it catches up again, and now it's switched back into heading mode again. And then the same thing, and then I really do want to get a real turn. I think this is it coming up here. So here we do a real turn. So now it doesn't realize till too late that the other vehicle's turned and loses track, and it has to catch up. And now you'll see that the airspeed of this follow vehicle starts ramping up and it's dropping points to try and follow the other vehicle. And the behavior has to be different depending on whether you're on the outside of the turn or on the inside of the turn with the following vehicle. Let's go back to this presentation. So this is the core of the navigation code, and I don't really need to go into it in a lot of detail, just to say that there's a whole bunch of logic around if I'm close to the other vehicle, if I'm doing a turn, if I'm doing a tight turn, in other words, I'm on the inside of the turn or on the outside of the turn. So several different circumstances, I figured out that I need to be doing heading mode when I'm flying to try and track the path of the other vehicle. And the other one is target location. So that's dropping points. And both of those are using the Mavlink command int interface that dropped into the Lua API bindings. So it's been really useful to have that. The fact that you can call pretty much anything that there's a command int function from Mavlink from Lua means, and I use those for this, but this I did have to make a couple changes in the low-level code because I'm running this at about 10 hertz, about 10 times a second. I want to update the location. If I run it lower, then I do things like I overshoot massively because a plane can travel, an awful long way in a second or so. The default is that it will ignore these messages if they come in quicker than every 3 seconds, and that's a bit long. So I'm proposing to put in a parameter that sets the limit to how quickly these messages can be interpreted, and I want to be able to run it at about 10 hertz to get it to work well. Getting the speed to match was actually the biggest challenge up front. No, not up front. It was the first thing I thought I'd solved and turned out to be the last thing that I really did solve. I went through multiple iterations of the logic of this thing, trying to figure out how to get the speed of the follow vehicle to usefully match the speed of the target vehicle. It seems pretty straightforward, but the problem is, of course, that planes don't have brakes fundamentally. And so if you have a following vehicle following the target and it catches up, you want it to slow down enough so that then it matches speed by the time it's right there. Because if you keep going fast enough to catch up, you'll probably end up going back beyond it. And that was happening an awful lot. And I put all kinds of complicated logic in until I talked to a friend of mine called Justin, who is an engineer by trade. And he basically said to me, you know what, you should be using a PID controller. And I thought, well, that's too hard and I don't really understand them. But sure, okay, fine. If you say it's easy, again, aerobatics Lua script from Tridge. He had a PI controller in for doing the aerobatics. I took that, dropped it in, created a module so that it can be just included, and that'll be part of my PR. Actually, I added a D as well. So there's a PID controller module that you can just require into a Lua script that will create a PID controller. And then the other part of the problem is the discussion around error. And I've learned enough about PID controllers, as someone explained earlier today, that it's the error that the PID controller is managing for you. I did something interesting, and I'm not really sure if you're supposed to do this, but it works. And that is, if you can look at the first one, I have one PID controller on the differential velocity between the two vehicles. That's what DV is for. But the error that I use is not a velocity error, it's a distance error. So I use the distance between the target vehicle, or the follow vehicle, and that point that I'm trying to hit with the offsets. And I use that as my error, but then I have the PID controller return me a velocity. So the first parameter being passed in is the differential velocity. My error is the distance. It actually works. It returns to me a differential velocity that I then feed into a second PID controller right away on one line below. And that one gives me a target vehicle airspeed based on using that differential velocity as an error. And so by cascading those two PID controllers on top of each other, it was a bit like Justin told me when, when a PID controller works, it will just magically work. And it really did. I deleted about 20 or 30 lines of code that was doing all kind of complicated things. And these two lines of code, that's what you saw flying. And it really quite nicely matches the speed now. It speeds up enough to get close to the vehicle, which is where my differential distance is the error, means that I don't overshoot. And then it matches the speed of the target vehicle, which is what the second PID controller is doing to give me, so that when they're beside each other, they will stay beside each other. And I do want to quickly show that one because it's quite nice. This is the last video I think that I have. Oh, no, I decided not to show you that one for some reason, but, and I won't change my presentation, but so that was, but since I've got it open, I'm going to show this too. This is a turn video, so we're just about to talk about the turning, and I think I might as well show you that one. And this is from the ground. I just love how cleanly that follow vehicle follows the other plane around. Sort of magical in a way. Sorry, I really like it. Okay. Let's go back to the presentation. All right. And that we talked about that. We talked about the two different guided commands that I used for doing the change heading and the change speed and change altitude and do reposition. Effectively, guided heading mode or guided heading mode in autopilot really has two sub modes. One is location and one is heading, and it can work either way. And I switch between them to make it work. Oh yeah, and attitude for turns. So that's where this video leads into this, and that's the last piece that I really wanted to talk about in terms of major challenges that I had to address, and then things that I believe I've solved. And like I've tested this and flown it multiple times, not just that one flight that you saw, and it really does work. But figuring out when the lead vehicle is turning is hard. If you just use the global position int, which is what feeds into the AP follow library. And I might just diverge a little to mention that. Most of what the Lua script is doing is relying on the core of what's already in autopilot. A bit like Nathaniel's message earlier, autopilot has a lot of stuff. It's already there and it's great and it's magic, autopilot magic, it works. And so what I do, when I looked at what Copter did, I found out that there's already a AP follow library in plane, and there were a bunch of bindings already there. So I didn't really have to do a lot. I just had to figure out what the hell it was doing, because it wasn't really that obvious, and there's some weird and funny names for the APIs and stuff. So I had to do a lot of reading of the C code, but I didn't end up having to change an awful lot to make it work. And what it effectively does is it gets a global position int message in Mavlink, does some math, figures out what the target vehicle is doing, figures out where the follow vehicle needs to be, and then throws that over the wall and says, okay, you figure out what you want to do with it. And that's where Autocopter has C code that figures out what you want to do with it. And now I've written a Lua script that figures out how to make the plane do something useful with that information. And what it was giving me was, it was giving me the location of the target vehicle and it was giving me the heading. But by the time the target vehicle's heading has started to turn around a turn, the follow vehicle's already massively overshot. And so I added pulling the attitude of the target vehicle. And so from the attitude of the target vehicle, I can find out its roll and its speed of roll. And therefore and then I project that ahead a couple of seconds so that I can tell. And I mean, that it probably needs tuning a little bit, but right now I use about 2 seconds, and I can tell that the target vehicle is going to turn. And based on some um, complicated maths, well, really high school maths that I can barely remember, mostly trigonometry, but I harvested the code, and thanks, Bob, for your help with this, out of Mission Planner, to calculate the turning radius from the roll and roll speed of the target vehicle. And based on the turning radius, then I calculate what the heading is going to be of the target vehicle 2 seconds ahead. And then I tell the target vehicle to start heading for that heading anyway, even if the other vehicle hasn't turned yet. So that's how that works. And oh yeah, I've got this other one. Um, should I do that one? Uh, I'm going to say no, unless someone asks about it. Um, but what I found was that I was also targeting a gimbal camera in one of my test vehicles to point the gimbal camera at the target plane as it was flying around. I was finding it was very glitchy. It would point at the target plane and then it would suddenly glitch back and all the time. And I finally figured out that it was telemetry. And um, and so what's actually going on is that if it's not getting telemetry updates quickly enough, the camera will keep pointing where the plane was for a while, and then it'll figure out it moved, and it'll suddenly jump. And it was good that I did that because that was a real cue to the fact that I wasn't really getting good enough telemetry updates to the follow part. And um, so it's one of the things that I've only just done, which is that I've started to increase the telemetry rate of the messages, global position and attitude coming from the target vehicle into the follow vehicle. And also there's some very cool work that Peter Barker and Leonard Hall have been doing with follow that I'm really looking forward to getting to when I can start to use it, because it's going to do um, kinematic interpolation. So it should be able to smooth out those gaps really in the information that I'm getting from the target vehicle and give me a predicted smooth path so that I can follow effectively the smooth path. Again, a bit like before, Autopilot has magical things that happen inside, and if you use those, you can do even more magical things on top of it. And so I think it'll make significant improvements both to that and also I think to the ability of a gimbal camera, which I'm going to be using Frank your CE8 mini camera. I plan to mount on the follow plane and then have the gimbal camera tracking the follow vehicle as it flies around. I think it'll be very, very cool. I did want to mention there's this weird offset problem. I already talked to Tridge about it. I'm not really sure what's up with it, but and maybe the kinematic interpolation will fix it. For some reason, the offset that I get from the target vehicle isn't quite right, and I end up having to apply like a fudge factor to it to get it correct. I parameterize most of the things that happen. Okay, I think I've talked about most of these. I just want to talk about some lessons that I learned here quickly. Um, you know, text can fly the plane. Text is amazing. A well-tuned text or a really nice text tune of a vehicle means that you don't have to think. You can just tell the plane to fly and it will fly. And so that's where it was really easy in the Lewis script to just say, go here, and the plane will deal with how to get there. And it really works. So some people have a tendency when they think about this thing to think, oh, I have to control the throttle, I have to control the ailerons, the elevator, whatever. You usually don't for this anyway, for this kind of application. You tell the plane what to do, it figures out how, and it really does work. AP follow does all the basics. Unfortunately, you really do have to read the C code to figure out what's going on. The copious Autopilot wiki documentation that I've tried to help improve working with Henry Wurzburg, who does an amazing job. And a lot of you have also helped here, but I think in this case it probably needs some more work, and I might try to help with that. PID controllers are magic, just magic. And they can do things that you really don't expect. When I learned that it did this, I'm already starting to think, is there a way that I can use them for the turning as well? Um, and yeah, uh, oh, telemetry rates really matter. And I kind of assumed that I'll just use what's there as the default and fix it if it's a problem, but I should have thought more about it. And now that I know how important they are, I'm going to have to start doing things like Trude suggested, is get the follow plane to request the telemetry, global position in attitude, and anything that I specifically want. And I'm guessing, I think at about 20 hertz probably. And then, of course, testing. Like any software development exercise, testing is everything. It's not done till it's tested. And in RDPilot terms, CIDL testing is amazing and gets you to a certain level. But then you really do have to take your heart in your hand and throw a plane in the air and see what happens. And I think in some ways I feel lucky, and in some ways I think it reflects what I've learned, and also a lot of the good work of almost every one of you here. Um, you know, Touchwood, I haven't crashed any planes doing the follow yet. And I do expect I expected that I would by now, and I probably will, but it's testing, testing, testing. I was very cautious about doing it, but it works and it's great. Um, I am not going to talk about this diagram. It helped me to think about things, but but what I would just do want to say is, and thank you very much. Questions? Just one or two questions. Okay,
Hey Tim, so quick question on, I know you talked about the SICK radio, but can you describe a little bit more of your telemetry setup? Is there multiple networks or a mesh? And then does your script handle if the follow plane doesn't get telemetry for some threshold, what does it do?
Yeah. So the SIK telemetry radios is a simple point to point between the two planes. Originally, I did set it up going through the ground station. The microphone can probably move while you, um, yeah. I did set it up going through the ground station, and the latency was just killed it. So I have a separate radio link for control of the planes. I'm using Express LRS. Um, and and then I have the point-to-point SIK telemetry radio between the two. The Holybro radios, Vincent, they seem to be doing mesh, because I can also connect to the ground station when I'm on the ground to two planes, and I haven't done anything special and it worked. What I was expecting though, and the question that if you're not going to ask it, many people have asked me this, is, well, can you do 3 planes or 4 planes or more? And the answer should be, I haven't tested it, but absolutely no reason why not, as long as you can get the telemetry. The vehicles have to have a different SysID this MAV, but technically you could have 2 planes following the lead plane and then 2 more planes following each of those planes, and you're pretty much limited by the 8-bit 255 limit on those Mavlink SysID, or the bandwidth of your telemetry links, and then you might have to design a more sophisticated way of doing it. Or what I plan to do, and I was talking to someone else here today thinking about this, is use LTE with basically internet connectivity. I'm thinking between the planes might be a good way to do it. Yeah, but I don't know. Does that answer the question? Hmm. Oh, yeah, yeah. So I put in some timeouts, really. There's a couple of timeouts One is that if it fails to get a message from the other vehicle in a certain number of seconds, which is a parameter, and I defaulted to 5, then it will flip into heading mode and keep heading in the same direction. And then if it, at a longer interval, which I defaulted to 20 seconds, I think, then it's again, a configurable, you can actually say, configure what mode you want to switch it into. So there's a variable of fail mode, ZPF fail mode. Oh, and I want to mention, I use this standard for my scripts now, where I put Z in front of anything that's scripting. So I have ZPF, Z plain follow, fail mode, and I default that to RTL, but you could specify whatever you like.
Thank you so much for a very interesting presentation. We've done with the sea rescue, we tried to do the same, but to follow rescue vessels, so AIS targets.
Oh yeah.
But there we have a problem with the telemetry basically
Yes.
from the vessel, because it's not as fast. But one very specific question is with the heading mode. We tried to do like an FPV mode over with our GCS, but we didn't find the heading or guided heading mode. Is that something you've implemented, or?
No, it's just there is a guided heading. It's the Mavlink message. That's maybe where it's coming from. It's actually underneath in the covers. Guided mode has a guided heading type, and it can take a heading from and I'm not sure how you send it to it except through an API or from Lua. But I switched to using the new Mavlink command interface. So with that, you can say guided change heading. And the Mavlink guided change heading command lets you set the heading in degrees that you want the plane to fly. And really all you need to do is change what I said earlier, is allow it to get more frequent updates. Because by default, if you send a guided change heading command right now, and then you send another one, it'll say, well, you have to wait 3 seconds before you're allowed to send me another one. And that's really not fast enough. But otherwise, that's how you do it. And that's how I did it.
Okay. Thank you very much.
No problem. All right. I think, oh, there's one at the back. Oh yeah, I want to do Peter. Please let me do Peter.
So really, this is just scope creep in the guise of a question. Yeah, you just mentioned the problems you were having with the mount being jerky.
Yes.
And that's kind of just a design deficiency in the way mount does SysID targeting. The fact that it just, when a message comes in, it just sets an angle. And oddly enough, the target's moving.
Yep.
So yeah, if we switch that to some form of rate control rather than angle control, things would probably work a lot better. We have the information, I believe, in the follow library. So
okay, thank you. Good. All right then. All right. Arigato gozaimasu.